Python. Class variables are shared among all instances, meaning objects, created from a class. Instance variables are defined inside of the constructor. Class variables are defined outside of the constructor. With class variables, they allow you to share data among all objects created from the class. With instance variables, each object has their own version. With a class variable, all those objects share one variable. Here's an example. We will create a class of student. We also need a constructor. When we create a student object, this constructor is automatically going to be called. All the to share are defined among object has their own vertex created from the class. With instance variables, to share data defined instance variables, got to talk about object-oriented programming using Python. Hey everybody, today I got to talk about class variables in Python. Class variables are shared among all instances, meaning objects, created from a class. Instance variables are defined inside of the constructor. Class variables are defined outside of the constructor. With class variables, they allow you to share data among all objects created from the class. With instance variables, each object has their own version. With a class variable, all those objects share one variable. Here's an example. We will create a class of student. We also need a constructor. When we create a student object, this constructor is automatically going to be called, but we need to pass in some arguments. We are provided with self. Self refers to the object we're currently working with. We will set up a name parameter and an age parameter. We will assign self, the object we're currently working with, set the name attribute to equal the data for the name that we receive from this parameter, and self.age equals age. Let's construct two student objects. We will have student1 equals, then call the constructor for student. So type the name of the class followed by a set of parentheses to invoke it. This will automatically call the constructor, but we have to pass in data for the name and the age. For the name, let's pass in SpongeBob, because basically everybody in the world knows who SpongeBob is. I don't know how old SpongeBob is, we'll say he's 30. We'll create another student object, which we will refer to as student2. We will call the constructor of our student class, pass in data for the name and age. Student2 will be Patrick. Patrick will be 35. Okay, let's make sure this works. Let's print student1's name followed by student1's age. And we should get SpongeBob, and his age is 30. Let's print student2's name and student2's age. Patrick is 35. Now we'll create a class variable. Class variables are defined outside the constructor, and they are shared among all objects created from that class. Each object has their own name and age property. These are instance variables. But class variables are defined outside the constructor. Each object will share this one variable. So if we're working with students, let's say there is a class variable of class year. What is the graduating year of this class? 2024. Now, let's print student1's graduating year. Print student1 dot class year. Okay, so SpongeBob has a class year of 2024. That's when he's graduating. Let's check student2. Patrick, his age is 35. His graduating class year is 2024. Now, with class variables, you can access them through any one object, such as student1 or student2. It's good practice to access a class variable by the name of the class, rather than any object created from the class. Since we're accessing class year, we'll access this class variable by the name of the class of student. Make sure the S is capital. This helps with clarity and readability. If I was looking at this print statement, I can tell that class year is a class variable because we're accessing it directly from the class, and not any instance from this class. Without looking at this class, I can't tell if class year is an instance variable or a class variable, but if I access it via the class name, it's more explicit. So it's good practice to access a class variable by the class name itself, and not any one instance of this class. Let's create another class variable. We'll create a class variable to keep track of how many students we have created. This class variable will be num students, meaning number of students, equals 0. So within our constructor, we can write any code that we want. This code will always be executed when we instantiate an object. I would like to take our number of students and increment it by 1 each time we construct a new student object. So instead of using self refers to the object we're currently working with. If we're constructing student 1, just imagine we're replacing self with student 1, or student 2 if we were constructing student 2. If we're going to be modifying a class variable, in place of self, we'll use the name of the class, student. Access our class of student, get the class variable of number of students, then I will increment it by 1. Plus equals 1. We are constructing two student objects. I will print access our class of student get the number of students and print it. We're constructing two student objects. If I print the number of students that we have, it should be 2. Then, just to be sure that this is working, let's construct a third student object. Student 3 equals student. This student will have a name of Squidward. Squidward's age will be 55. Now we have 3 students. And for good measure, let's construct one more. Student 4 equals, we will create a new student with a name of Sandy. Sandy's age will be 27. The number of students is now 4. Just as an exercise, using an f-string, let's print the student class's class year as well as the number of students. I will print, use an f-string, my graduating class of, let's add a placeholder, access the class of student, then access the class year. My graduating class of 2024 has, then we need the number of students. We'll add a placeholder, access the class of student, access the number of students, has blank students. Let's see if this works. My graduating class of 2024 has 4 students. Now, if I were to change 2024 to 2025, my graduating class of 2025 has 4 students. Let's print the name of each student. These are instance variables. Student1.name. Then we need student 2, 3, and 4. My graduating class of 2025 has 4 students: SpongeBob, Patrick, Squidward, Sandy. All right, everybody, so those are class variables. Class variables are shared among all instances of a class. They are defined outside of the constructor. The benefit is that they allow you to share data among all objects created from that class. And well, everybody, those are class variables in Python. What is going on, everybody? So today I got to talk about inheritance in Python. Inheritance allows a class to inherit the attributes and methods from another class, much like how a child in real life can inherit traits from a parent. By having a class inherit attributes and methods from another class, this helps with code reusability and extensibility. In this example, we're going to create an animal class. The dog, cat, and mouse class will inherit attributes and methods from the animal class. We will create a class of animal. Then I will define the constructor. When we construct an animal object, let's pass in a name. It's not required, but it might be good for this example. We will assign the attribute of name equal to the name we receive. Let's also add an attribute of is alive. Whenever we create an animal, we will set their isAlive attribute to be true, and that is a capital T. All animals can eat. Define eat. We will print, using an F string, add a placeholder, self.name, the name of this animal, is eating. All animals should be able to sleep. Define sleep. Print, I'll use an F string, insert self.name is sleeping. And that is all we need for the animal class. Let's define class dog. For a child class to inherit the attributes and methods from another class, after the class name that's going to inherit, we need to add an inheritance list with a set of parentheses, then list the name of the class we're inheriting from, the parent. The dog class is going to inherit all of the attributes and methods of its parent, animal. For the time being, as a placeholder, I'll add pass, just to demonstrate this. Class cat is also going to inherit from animal. And class mouse will also inherit from animal. Okay, I will collapse this for now. We'll create a dog object, dog equals dog, then pass in a name for this dog, because we have one parameter set up of name. This dog will be named Scooby, as in Scooby-Doo. Cat equals, call the cat constructor. This cat will be named Garfield. And mouse. Mouse equals mouse. Our mouse will have a name of Mickey. Even though there's nothing within this dog, cat, or mouse class, we should still have these attributes and these methods. If you inherit the animal class, you should have a name attribute, an isAlive attribute set to true, you can eat, and you can sleep. Let's print our dog's name. Dog.name. Scooby. Print dog.isAlive. Our dog is alive, that is true. Let's have our dog object use the eat method. Scooby is eating. And sleep. Dog.sleep. Scooby is sleeping. Let's replace dog with cat. The name of the cat is Garfield. Garfield is alive. Garfield is eating. Garfield is sleeping. And mouse. Replace any instance of cat with mouse. Our mouse's name is Mickey. Mickey is alive. Mickey is eating. Mickey is sleeping. Even though these children classes are empty, we're still inheriting these attributes and methods from its parent, of animal. This is convenient because you don't need to copy and paste these attributes and methods for every single class. For example, if I were to copy these attributes and methods and paste them, well, we have a lot more code to write. And as a consequence, if I need to make a change to one of these methods, I would have to do that to every single instance of this method. For example, let's replace is sleeping with is asleep. Well, now I need to find every single sleep method and change it manually. It's not too bad if you only have a few classes, but imagine if you have hundreds of classes. That's going to take a lot of work. It's a lot easier to write the code once and then reuse it, and I only need to make that change in one place, rather than make that change many times. So let's change is sleeping to is asleep, and see if that works again. Mickey is asleep. Let's replace mouse with dog. Scooby is asleep. Not only that, but with children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods, and they can speak. Let's create a speak method, and I will print a unique message for dogs. Woof. Cats will also have a speak method, but it's going to be different. Cats will meow. Then for our mouse class, they will squeak. Let's have our dog speak. Woof. Let's have our cat speak. Meow. And our mouse. Squeak. Alright everybody, so that's an introduction to inheritance. Inheritance allows a class to inherit attributes and methods from another class. Much like in real life, a child can inherit traits from a parent. These are also known as sub and superclasses, which is a topic for another day. Inheritance helps with code reusability and extensibility. If all of these children classes inherit these attributes and methods from another class, we only need to write that code once and not copy it for every single class that needs it. We can write and change the code in one place for better reusability and extensibility. And well everybody, that is an introduction to inheritance in Python. Hey everybody, so today we got to talk